That's just at the beginning of the video. And in some cases, if things look like I'm showing something big, I can adjust it. See this area off? It's also delayed. There's a slight delay. Now it's lined up. You can also zoom out. You want to make stuff down? Does that make sense? Set up the microphone.
That might make sense for me. It's a little bit better.
But yeah, we're going.
We're live? All right. Well, my name is Sam Harmon. I'm with Makers Alliance, and for whatever reason, I designed this year's Notacon badge. So, first thing I want to do before I really get into any details about this year's is I want to talk about previous badges. What went well, what didn't go so well, because I've pretty much been involved with helping nearly everyone solder their badge. So we'll start with the Notacon 8 badge, which is this little N-looking thing. It's pretty good. It was based on Arduino, so it worked pretty well. You know, everybody was able to do some cool hacks with it. Like I turned mine into like a little MIDI arpeggiator, but it had some kind of faults. Like it needs like a special USB to serial adapter in order to program it. So not everybody has one of those. We had a couple around that people could use, but it also had, if you wanted to get one, it's like $15. And then there were add-ons for it, like there was a gas sensor that nobody, I think, actually was able to get working right, and this capacitive touch strip that I don't think anyone got to work right. Then the chips came non-programmed, so I had to, burn all the bootloaders onto the chips using my old Atmel STK 500, which is actually serial-based, not USB. It's really flaky. I think we only broke a couple of people's, pins on their chips and then had to replace them. But otherwise, it was a pretty good board. Then the next year, Notacon 9. I don't have that one with me because I loathe it so much, and it's somewhere in my room full of electronic stuff, and I couldn't be bothered to find it. It was PIC-based, which I'm not against, PIC chips or anything. It's perfectly fine. It's just that nobody had any documentation really on how to program it. The guy that designed it didn't actually have like a physical prototype made. He just kind of said, "Here are the files. Go get it manufactured." And we found some really serious problems. Like things were marked on the silk screen as going in one way, and no, they actually had to go in backwards. And we had to find this out on the fly during Notacon 9. Luckily one person actually had a PIC programmer on site. He was able to get something onto, some of the badges for people. And I'm not going to talk about that badge anymore. So then we get to last year, Notacon 10. And that's this badge here, the based on the 101 Radio Shack experimenter set thing. This is pretty cool. But it had a couple of flaws too. I mean, it was neat that it's got all this stuff on it, like 4 NAND gates, like a dual op amp, a 556 thing. So you could like make all kinds of crazy noises and flashing lights, sorta. The problem is it didn't have any extra tie points for these, so you just have like one point that you could go to, and if you needed to split that signal out to like a couple of different places, you kind of couldn't, unless you added this extra breadboard on like I did. So I had this like crazy thing going that actually did some cool stuff, but I couldn't wear it anywhere. So kind of a problem, but otherwise pretty cool badge. So the day that Notacon 10 ended, I said the only way that I'm gonna have a badge that's cool is if I design it myself. The other three, they were designed by other people. And I started thinking about it, and I had this really, really cool idea, because there's there's actually this chip. It's called the LPC1114. It's an ARM Cortex M0. It runs at like 24 megahertz or 30 megahertz or something, and it's available in DIP. It's like a 24-pin wide DIP, but it's in DIP, so people can solder it. Mortals. And maybe this will still happen in the future. And I thought about some other things, like some of the high-end picks, like MSP 430, maybe, some other things. And thought about it. I didn't really get anywhere with it. I bought some LPC 1114s and, started breadboarding them, but that's as far as I got. I got busy with a bunch of other projects, so, didn't do anything. Then, sometime around January, Froggy asked me, hey, are you going to do the badge this year? I was like, yeah, I definitely want to do it. I got this cool idea. I'm going to use this, like, crazy LPC 1114 through-hole ARM chip, and it's awesome. I don't know if we can afford that. And people want a badge that, they don't have to, like, really, install, like, the full set of ARM development utilities and get whatever kind of crazy programmer you're going to need. And, so we need it low cost and easy to use. And can you make it look like a T? Let me think about this. Because if you notice, the other previous ones look like an N and an O. So we're eventually going to spell out Notacon. So I had to think about it. And while I was thinking about it, we got to work on this project that Makers Alliance was going to do for Mini Maker Faire. And as part of our brainstorming, we were looking at VUSB stuff like Adafruit, Gemma, and Trinket. We were making this kind of cool LED ring light nonsense thing. We actually have a few left if you want to make one. And we were looking at these VUSB things. And while I was looking at it, I found this thing called the USnooBie. It's open source. It's got built-in USB to it, so you don't need like a special programmer to do something. It's more or less Arduino compatible. And I'm looking at the parts list, and there's almost nothing to it. It's cheap. Okay, I think we're going to do this. So I then took that design, which, if I use this one, it's really just this part of the board. That's the original design. So I said, okay, I can, do some magic in Eagle and add on this little prototyping area so you can like do your kind of cool hacks to it and, make it look like a T. So, and, I set up the prototyping area so that it will actually handle like a standard width, narrow IC. So you can put a couple on there, do some cool stuff, hopefully. So I then sent that off to a place called OSH Park, which used to be called like the Dorkbot PDX, PCB group buy thing. And eventually the guy, he kind of spun it off into sort of a little business called OSH Park, since it's all kind of organized around open source hardware. And that takes about 10 days for turnaround, which is pretty good. And I got 3 boards because that's kind of the way that his service works. You send for whatever you send them your file, and you get back 3 PCBs. And it's like $5 per square inch. Not bad for that kind of turnaround and whatnot. So while I'm waiting for that, I figured out, I'm gonna have to like burn bootloaders onto these chips, and I want it to go much more smoothly than it did at Notacon 8. So I put together a little AVR target board, and I put a ZIF socket on it, which has maintained my sanity in this process. Because otherwise I'd be like putting in the chips and pulling them back out with a pin extractor. Instead, put the chip in, flip that back, it's insecure, burn the bootloader, pop it back out, done. So yeah, that thing has maintained my sanity. However, when I was setting it up, we had some issues just trying to get it to program right. It turns out this is just AVR Dude, which is kind of the standard program for command line uploading of stuff into an AVR chip. That just was giving me some grief about bit masks on the lock bits. And it turns out those bits aren't used, so just zeroed them out, it's fine. So then the boards arrived, and I discovered, I made a small error. The text on the back, which, just says like makersalliance.org to, give us a little props, and, a little Notacon.org. I got the text backwards. This happens. But otherwise, looks pretty good. And I put it together, and it turns out that from that parts count from before, it turns out there's some stuff you just don't need. There's, if you really want it, there is like a spot for a 3.3 volt regulator and some other stuff, but you don't need them. So we tested it, and because of the way that this works, you can use the Arduino IDE, but you have to make a little modification to it. Oh, yeah, I should do that sometime. So yeah, you have to add some stuff. It's pretty simple. It's a text file. You just add some copy and paste, and you're done. And try to upload just a standard Blink sketch. The IDE gave me like a weird warning, but the program ran. So I don't know what's going on. And we double checked it on somebody else's Windows machine. Gave kind of the same weird warning, but it still uploaded, it ran. So you might experience warnings when you try to upload programs on yours. We'll see. Then, knowing that it's good, then we say, oh, well, we should probably, fix it up and make it look pretty for production. Then I had to learn how to go from having the generic vector font of Eagle on the badge to the actual Notacon logo. This is not trivial. Try to just import. There's a thing for importing a bitmap into your Eagle file, and it didn't work right. It puts it in the wrong layer. It only wants to put it in like one spot on the board. It was a mess. So I had to do some research, and I find out, don't do it that way. Create your logo as a part in your own like personal parts library. Then you can add that part onto your board, and then you can place it wherever you want, and it works really nice. Then I had to go through some trial and error to get the scaling to look right, and make sure it's gonna fit in this space and all that stuff. And then I fixed the mirrored text on the back and added a little bit of props for Frank Zhao, the guy that designed the USnooBie and that kind of stuff. Then I had to learn how to actually make Gerber files in Eagle. Because usually if I'm just dealing with OSH part, I just send them the Eagle file, they do the work. So actually SparkFun has a pretty good CAM job that you can just run within Eagle, and it gets all the stuff you need to write. And we sent it off to Cleveland Circuits, and the only thing they complained about was actually the lanyard hole. They just weren't sure what to do with it, and we just said, yeah, that's just a hole for a lanyard. It doesn't need to be plated or anything like that. Just cut it out. And where are we now? Well, as of last night, something like a half a dozen people have put together their kits. I was actually there with them. Most of them worked. Obviously there are some minor issues that just some people had like mis-soldered a spot here or there, put in like the LED backwards, that kind of thing. No biggie. But we had a few up and running, and I want to thank those guys who were there late last night, for kind of being beta testers. And what we've discovered so far, there's a resistor up at the top. That should have been probably an 1/8 watt. The silk screen is really kind of looking for that, and the pin spacing is kind of looking for that. We're including a 1/4 watt in the kit, so it's not going to fit quite right, but it'll get in there. It'll be fun. And then if you actually look at the USnooBie documentation online, a lot of this is in there. But then you want to set your voltage select jumper to the lower 2 pins to tell it it's 5 volts instead of 3.3 volts because we're not including that 3.3 volt regulator. And there's usually on this, and it's on the silk screen, there's a diode that can go on there for reverse current protection, but for common applications, you don't need it so much. And the one that he spec'd out, we couldn't find, and the common, like the kit that you can actually buy from Seed Studios doesn't include that diode anyway. So most people just put in a wire link there. And as of last night, all the kits should have bootloaders installed. I did half of them Tuesday and half of them last night. And if for some reason I just spaced and didn't install it, just come and find me. I'll set you up. And then as far as programming, once you get it all put together, if you're on Windows, you will need to install like a special driver to handle the VUSB or USB ASP programming for this. If you're on a Mac or Linux, it should be fine, just kind of built in. And if you're going to use the Arduino IDE to program it, you're going to have to go into the boards.txt and set up the stuff. And that's all on the USnooBie website. And the actual procedure of programming it, there are 2 buttons. Let's see, there's the reset button and the bootloader button. So you have to press the reset button and hold it, press the bootloader button and hold it, release the reset, release the bootloader. Then you want to wait a second or two before the bootloader actually starts running. And then you can press the upload button on your Arduino IDE. Or if you're going to be hardcore and use AVRDude directly, run AVRDude to get it in there. And I think that's actually the last slide I have. So if anybody has any questions or comments or whatever, I'm all ears.
I have a question.
Okay.
Do you recommend putting any of the parts in through, let's say, the back versus putting them?
Oh yeah. So he asked if there was any advantage to putting in parts through the back rather than the front. Not really. You certainly could, but I don't see any great advantage.
What are the 3 parts that are inside the center of the chip?
Those are actually capacitors. They're the 2 capacitors for the crystal, and then those are like 27 PF, and then there's a 0.1 microfarad just power regulation cap. You could put them in that way, but usually they're just covered up by the socket. So you just solder them in, then you put the socket on, and that covers them up pretty nicely. Yeah.
It's great that the virtual USB system has made Arduino so much cheaper. I'm wondering if you think that perhaps that would help make use of Arduino more widespread, perhaps with the things.
Okay, so the question was, or not, yeah, kind of question, I guess was, with the prevalence or, recent addition of VUSB to kind of the Arduino ecosystem, is it going to, make Arduino more widespread, especially for Internet of Things applications? And I don't know if it can get much more widespread. Arduino is a pretty prevalent platform nowadays, and anything that you want to do, there's probably someone else has already done it and they've documented it really well. But yeah, it would certainly increase usage just because it's going to cut the cost. There are a couple of trade-offs, like you lose a couple of pins to the VUSB stuff. So if your program is going to use, I think it's pins digital 2 and digital 7, you're going to get really weird results probably. So don't use them. But other than that, I think all the other standard Arduino pins are exposed out. Anyone else? No, as soon as I get everything packed up here, I'll be over in the atrium in the hardware hacking area. So if you have any further questions or need some help getting your kit together, you know, myself or someone else will be around to help. Got a question?
You said the build instructions are on the website?
Yeah, it might be easiest to just Google the USnooBie and get the instructions there. But otherwise, there probably is a link to it from the Notacon site somewhere.
You want to spell that out?
Sure. Yeah, USnooBie. It's capital U, capital S, lowercase n, O, capital B, lowercase I, lowercase e. It's all, the text of it's also on the back of all the production badges. Anyone else? Once? Twice? All right. Well, thanks everybody for catching my little talk, and have fun hacking your badge.